Welcome to module number 6. In module number 6, we have come to a point where we've done a lot of work when we're attacking a system. Maybe on the red team, maybe as a contractor, you are going for the hack on this system. So what have you done? Well, first of all, you or your team has done footprinting. And with footprinting, you've gone over the organization, the employees, the structure. We've looked up things in databases and so on to find out as much information as we can. The next phase would be to go into scanning. And we went into scanning, we used Nmap, we used other tools to both establish that there were live hosts on the network and then to pull down information about ports and protocols. Then from there, we took that port and protocol information and we enumerated it, banner grabbed, got information about the software that was running, versions of that software that were running. And then the next thing that we did is went into the area where we talked about vulnerabilities. And we found out there might be vulnerabilities. And maybe on your journey in this fictitious tale, you have discovered that there are dozens or scores or more vulnerabilities that you've found. And now we get to the point where it's time to exploit those vulnerabilities. And that is what brings us to system hacking. So let's have a look at it. System hacking is split into 4 different sections, but don't let that fool you. We have quite a lot of information to cover. We're going to start off in number 1, demonstrating the different password cracking and vulnerability exploitation techniques in order to gain access to that system. But gaining access to the system is not enough, because then we go to the second learning objective. And in this section, we're going to use privilege escalation techniques to get administrative privilege. Often this is called going for root. We want root access. We want administrative access so that we can do whatever we want on that system, leading us to be able to do whatever we want on the entire network. Next, we're going to go into learning objective number 3. We're going to try to hide the malicious activity and maintain remote access to the system. And then finally, we're going to hide evidence of compromise. It's going to take us in a wild ride of a lot of very fun areas, fun topics. We're going to zoom in closely. We're going to be looking at code. We're going to be looking at memory and many other items. Let's get started. Okay, so in our first learning objective, we are going to be concerned with cracking into a system, cracking passwords, taking those vulnerabilities that we found and taking advantage of them and running with them. And so let's have a look at some of the areas where we can crack into that system. The first one that we want to look at is SAM. SAM, what is SAM? SAM is a security system that you'll find on Windows workstations. And a lot of you work with computers all the time. And one of the things that I find is I get contacted by relatives and friends, and here's how it will often go. You know, I've had this laptop in the attic for a year, and now my daughter's going off to college, and I can't remember the login. Can you crack it for me? If you ever did that, or if you ever want to do that, you're going to be cracking the SAM. Now, what the SAM is it's a password hash that is stored on the computer system. Let's have a look at it over here. So what we're looking at right here is PWDump 7. PWDump is a very nice little tool, and what you can do with it is you can go to where the SAM is stored and you can dump the hashes for the SAM. You see here we have an LM hash and an NTLM hash. Normally on a Windows 10 or 11 system, you're only going to get an NTLM hash. And then what you can do is use other tools to crack that hash, maybe using rainbow tables or other techniques that we'll look at in just a little while. We're going to see this tool on the far right, Mimikatz. That is an amazing tool to not only grab hashes, but to use it in a variety of attacks against Active Directory. That's what we'll be using that. And then Hashcat is great, dsinternals. So there are a lot of tools. We'll be talking about many of them. So what we do with the SAM is the next thing we want to do is kind of understand how it works. And so what happens is we have an authentication process. It's called the NTLM authentication process. This process occurs when you have a peer-to-peer network. In other words, you're not using Active Directory. So when I want to establish a connection to a resource on the network, that resource and my workstation exchange that password hash. So if you look at it over here, what you see is we have the client computer and there's a hashing algorithm. We send back, and it says DC here, but an Active Directory domain controller, unless you really mess it up, is not going to be exchanging a hash. But either way, you finally gain access to the resource. What the domain controller is going to be doing, instead of exchanging hashes, it's going to be using Kerberos. Kerberos is the major security tool in Active Directory, and it uses a system of ticket granting tickets and tickets. And I'm going to simplify Kerberos here. Essentially what happens is the client computer will send in a request for authentication. They'll be granted a ticket granting ticket and make use of that ticket granting ticket to get to a resource. In order to get to that resource, you have to be granted a ticket. So there's a difference between ticket granting tickets, and we'll explore that a little bit more as we get into hacking Active Directory. So with password cracking, there are many different ways to do it. Let's have a look over here at some of the methods for password cracking. One of them would be non-electronic attacks. So this is where we're going to be doing essentially social engineering. That is one of the best ways to get a password, but you can also look at it while someone's typing it. We have active online attacks. These are the most exciting, the ones you read about more often. Dictionary, brute force attacks, hash injection. We'll talk about a lot of these. Passive online attacks, and we're just sniffing, or we're doing an MITM, a man in the middle. And then offline attacks is where we take the hashes and we offload them and we use resources to crunch that or those materials that we have. So with an active online attack, we have the idea of a dictionary attack. Have you ever seen a password dictionary? So when you go online, you'll find that there are these dictionaries, and they can have millions, even tens of millions in some cases, of passwords. And we have passwords that have been cracked before. We have some of the most common passwords like password 123. If that's your password, you should change it. You'll find, if you look at some of these lists, that they are the names of football teams or something like that. So you have hundreds of thousands or millions of entries in these. And so what we do is we use these dictionaries to try over and over again with these passwords until we're able to break into there. So we have a dictionary attack, but we also have a brute force attack. Now this one is tough, because what happens is you take the password, you try every combination of that password. The longer it is, the longer it'll take to do it. My problem with this is, statistically, when you look at how long a brute force attack takes, you get to the age of the universe. And there you are, waiting for your brute force attack as all the stars turn into black holes, and eventually the universe gets sucked back in, and then you have to wait for another universe until your brute force attack is finished. And I usually, after a couple million years, I'm usually tired of waiting. Joking aside, this doesn't do a very good job with long passwords. And what we have as a technology that's coming in the very near future is a high qubit quantum computers that will be able to do variants of the Shor algorithm to be able to help with brute force. But right now, yeah, that doesn't work very well. And then another one is a rule-based attack. With a rule-based attack, what happens is you know something about the password. Let's say that there's a company and it's company name dash the password. Company name dash password. So I already have half the password, or at least a good chunk of it. if I just put in the company name. All right, so now let's have a look at some of the steps that we use to perform these attacks. So let's head on over here and look first of all at the steps, and then we'll just zoom in a little bit and see how that looks when we do this. Also, you will find in the lab we're going to be doing a lot of this work. First of all, we're going to obtain a word list. So very often what you'll need is one word list of usernames and another word list of passwords. And we're going to go pop that in the user share word list directory. And then we're going to create a customized dictionary of passwords. You want to tailor these as much as possible to the target. And then you're going to run these commands to generate that customized dictionary. And so this is the John. So John, that command, we're going to be using this in the lab, and we're going to be using it in another slide coming up. But it's John the Ripper. Give it the path to the word list. And then you run John the Ripper with the word list with the path to those word lists. And then you hit enter. And once you run John the Ripper, it'll churn through. And eventually, if the password is on that word list, what it will do is it will find the password and crack into it. So that is a dictionary, or actually this is a dictionary. This is not a brute force, but it works really well if you have a good word list. All right, so we have also active online attacks. This is a PTH, and we're going to see various variants of the PTH. So let's have a look here and see what's going on in the PTH here. So if you look at the user computer on the left, the first thing this user is going to do is log in, and they're going to have hashes in a SAM file. And then if you look at the hacker on the other side, the compromised server is, he has already compromised that server using some type of exploit. And then he injects hash into that. And now, because of that hash injection, he has access to anything that the user is doing. And so we'll see that there are many variants of this, and we'll get into that in just a few minutes. All right, so I want to talk to you about another variant of this. It's sort of similar, but in this case, what we're doing is we're grabbing the hash, and then we're using that to exploit the system. This is called an LMNR NBTNS poisoning attack. LMNR is link local multicast name resolution. What is LMNR? Well, what it is when you're on a Microsoft network, if you are trying to get to a folder, you need to know the machine name in order to get to that folder. So let's say it's called Workstation 5, or let's call it Server 5. It's on a server. And that name needs to be resolved. Now, I'm going to tell you the best way to resolve that name is not with LLMNR, with NetBIOS over TCP/IP, which is that NBTNS. Instead of doing that, you should just be using DNS. But that aside, if you're using this technique, then wow, it is very hackable, and the hacking is actually very fun. You'll see this in the lab. Let's go over here and have a look at what happens. So the first thing that you're going to do is you're going to go to your Parrot Security Linux box, and you're going to be using Responder. And with Responder, you're going to specify the interface that connects to that network. And then once you do that, you hit enter, and it waits. Let's go to the other side over here. And what's going to happen while it's waiting to respond. And so let's say that there's a user, and the user wants to get to a resource on the network. So he types in whack whack server name. Whack whack, I'm not quacking like a duck. No, whack whack is //, just how you say it in Microsoftese, //, and then the name of the computer. In this case, it says data server. Now, what's going to happen, you'll see this in the lab. Don't get fooled by it. I have so many students that when they see this, they stop working in the lab because it freaks them out. What happens is there's a pop-up that happens that says, I'm sorry, I can't get to that resource. But that is a fake response. Let's go over here and have a look at what actually happened. So Responder sent that fake message saying that it can't get to the resource. Meanwhile, it captures the login hash. Once we capture the login hash, then we can go to John the Ripper and use that in order to crack into it. So anyway, that's how that one works. You'll see this in the lab. The next one we're going to look at is going to be using Kerberos cracking. So let's have a look at this slide here. And so what we're going to be doing here is called ASREP roasting attack. And what we're doing here is we are taking advantage of somebody who has misconfigured Active Directory, and they set the do not require, see that right there? Do not require Kerberos pre-authentication. If they did that, we're in trouble. So we can use a couple different tools here to extract the password hash of the computer because of that misconfiguration. But let's look a little bit further. What we see here is that they are looking at the Kerberos protocol, they're targeting Active Directory, and let's go over here to the slide here. We'll see that they are extracting the password hash from that TGT service. What are we using for this? We're using Rubios for this one. Rubios is actually pretty cool. And then we can use Hashcat and crack into that system. So a couple different tools that we use. I would say it's very easy to do, but it's only easy when that Active Directory is misconfigured, unfortunately. And this can happen. I've seen this with small businesses, medium-sized businesses. I really haven't seen it with large organizations, but what'll happen is you'll get a new network administrator that is not as familiar with Active Directory. And when you're setting up Active Directory, there are all these fine-tuning settings that you can do for your domain controllers. And some of them seem like they might be enticing. Like, well, maybe if I do this, it'll make Active Directory better. It won't, because the default settings are actually fairly good for Active Directory. The second thing that a lot of these attacks are going to be made possible because of is backward compatibility. Active Directory might be installed on a network, and there was a previous network or there were previous applications that required the settings of Active Directory to be fine-tuned, and in doing that, we make it more vulnerable. All right, so let's have a look at the next one. This is called a pass the ticket attack. And so this one, we're going to be using Mimikatz to pass the ticket. And so we're going to, if you see the little window at the bottom right-hand corner, you see that little circle? That's the Mimikatz emblem. We can use Rubios and other tools to do this. But what we're doing is we are creating a method whereby we can grab pin codes, Kerberos tickets, etc. And we'll see this a little bit later when we get into the lab. We're going to run one of the pass the ticket attacks in the lab. Also, we have NTLM relay. And anytime we're dealing with NTLM, one of the big problems is it's so hackable. And so it's very important, where possible, not to use NTLM. Remember, I was telling you in the previous module that NTLM means old. NTLM means hackable. So let's have a look at what we're doing with a NTLM relay attack. And so we are intercepting, as you see at the top line, and relaying the authentication request, giving us the ability to impersonate the actual person or the client or the computer that should be doing the communications. So if you look over here, we're doing something that we're seeing a little bit earlier. We're running responder, and we tell it to go to ETH0, and we're going to wait for somebody to try to get to a resource on the internet, on the network in this case, and then we capture the NTLM v2 hash. Now let's go over here to this side, and there is a very, very cool tool. This is called Impacket. And so Impacket will set up the relay, and as you notice, we're going to home attacker responder logs and getting that hash, and then we'll be able to dump the hashes of the targeted system, and then we can crack those hashes, maybe using John the Ripper. Like usual, there are a lot of tools, and each of the tools that we use for cracking systems has a variety of parameters and a huge array of methods for their use. So one of the areas that can be very helpful is when we're doing it with AI because we can have the AI do the work for us. So let's go back to the board and have a look at what we're doing with a shell GPT over here. And so what we're doing is we're going to be using the shell. We're typing in SGPT and we're doing use Hydra. So that's the tool we're specifying to perform an SSH brute force, an IP address 10.10.19 using, and this is where we specify our collection of usernames and passwords and the location where those word lists are. And then we run the attack. But there are other tools that we can use that don't even involve AI. And one of my favorites is Loftcrack. Have you ever heard of Loftcrack? Loftcrack has been around for a long time. And what happened is it was sort of open source for a while. And then for a while it was closed source. And now it's open source again. We're going to do a lab with Loftcrack in it also. You can find it, download it, it's free. Run it, crack things. There's Loftcrack, there's Brutus, BruteX, there's a secure shell brute forcer. And over here, we're just using Hydra to run that attack. So lots of different tools available for attacking passwords. And so let's have a look at one of the techniques that we can use to defend against that. So what happens with a lot of these tools is, let's say that there's a 7 or 8 character password. That is fairly easy to crack if you have a very good dictionary for those hashes. You want to crack those hashes. But if you want to defend a common or easy password, what you can do is you can just put some random stuff at the end of the hash so that it will not match any other hash. And that is called password salting. By the way, this is a look ahead into the class, because the very last topic I'm going to talk about in the entire class is password salting. It's called key stretching, making that even longer. So keep that in mind when we get towards the end. All right, so let's have a look at how to defend against password hacking. And I really think that most people in this class already know some of this stuff. So we'll do a quick overview. So let's have a look here. And if you look at number 1, ensure that you follow the best practices when setting a password. One of my favorite best practices is to use a passphrase. In fact, you could look this up. If you go to your browser, go to a search engine and do a look up of password entropy, and then the keyword that you need here is XKCD. So password ENTROPY, XKCD. And a lot of you are like, XKCD, I know that. That's the comic strip for nerds and geeks. It's really a cool little comic strip. So if you do that, what you'll see is there's like a 6-panel comic strip. The last panel says horse, battery, staple. And what they're showing in this one is that in order to make a password less crackable, you need a high entropy password, which essentially means that it needs to be a long phrase. But it doesn't have to be something that is so random that you can't remember it. You can make it something easy to remember, but very long. So a 20-character passphrase can be very easy to remember for humans, but extremely long in terms of the phase space that it would take to crack that password. So that's number 1. Number 2 is audit. Number 3, don't share your password. So for instance, I would never tell you that I use password 123 on all of my accounts. I'm not going to tell you that. All right, next thing we look at is number 4, don't use clear text, use encryption. Number 5, set your policy to 30 days. So the password expires in 30 days. And this one is enable syskey, but I want to give you a warning about syskey. Syskey was, notice I'm talking about it in the past tense, was great, because what it would do is take that hash that you're using with the SAM, with that large NTLM hash, and what it will do is it essentially sort of salts it. It protects it so you can't get to it. But it's another thing you can look up on a browser tab. Type in syskey scam. Syskey scam. There are scams, and scammers would use syskeys to take over people's systems. So you know what Microsoft did? They said, forget about it. You can't use this anymore. And they deprecated syskey, and instead they want you to use whole disk encryption. So you see what I'm talking about if you look up SysKey scam. The next thing we look at is we're going to be monitoring logs. We're going to be making sure that we are careful that we find out where passwords are stored, make sure nothing's in clear text, do account lockout, so if they try 3 times to get locked out or something like that, and also geolock accounts. So in other words, if I take a device out of a certain area, it locks. All right, so now let's have a look at the next phase of this, and we're going to take the vulnerabilities that we found in the previous section and we're going to exploit them. As you look at this slide, we see that there are 7 different areas that we're going to look at. Number 1 is we're going to identify the vulnerability. Number 2, the risk. Number 3, we're going to look at the capability, what it'll allow us to do. We're going to develop an exploit. And that word develop is actually pretty salient because sometimes you actually have to write your own code. We're not going to do that in this case though. Number 5 is select a method. We might be able to do a remote or right there local on that system, generate, deliver the payload, and then we're going to gain remote access. All right, let's look at the first one. So you can also do this too. If you wanted, you could open up the Google Hacking Database. And in the Google Hacking Database, you go up to the little spider, the little bug on the left, and go into exploit, and then you can type in a search. Like for instance, let's say Linux, you type in Linux and there are all these Linux exploits. You type in almost any app you can think of and there are exploits against it. And each of them have it's very nice because you have the built-in code. And so you don't even have to build your own code for these exploits. It's all there already for you. And so the Google Hacking Database is a great place to start. And hopefully, for your client or for your systems, none of your systems or apps or anything are listed on the Google Hacking Database. If they are, it's time to do a little bit of fixing. All right, so other tools that are very helpful in exploiting vulnerabilities. This is one, let's have a look at this slide here. This is one called WesNG, or the Windows Exploit Suggester. A very cool little Python-based tool that will actually go through and look at the network and suggest an exploit for you. It's actually pretty cool. Another one that we have is one that you've probably heard of before, and we've used it in the labs a little bit before, and this one is Metasploit. Now, let me back up a little bit and talk about Metasploit. Metasploit is a hacking tool that is useful for every phase of hacking. It is very flexible. It runs on Linux. It runs on Windows. But I will give you a warning. If you ever decide to install Metasploit on Windows, you need to dedicate the entire computer to Metasploit because it makes global changes that make that laptop almost unusable for anything else. So I like running it on Linux. We already have it on Parrot Security Linux, and it's very easy to use from there without having to install it. Other things about Metasploit. If you look at how it's set up, we have libraries, we have interfaces, we have modules, we can interface all kinds of security tools, we can write extensions to Metasploit. I often call Metasploit the baby universe of hacking. So we go into the exploit part of Metasploit. It's an exploit module where we can configure an exploit and verify. And in the lab, what we're going to actually do is you'll see that we can run through a verification, select the target, select the payload, and once we have all that stuff put together, we launch the exploit. There are also payload modules and auxiliary modules. This makes Metasploit extremely extensible, where we can establish COM channels, execute arbitrary code. And by the way, that term, arbitrary code, whenever you see that, that is a bonanza for an attacker. That means you can put whatever you want into that slot. So being able to execute arbitrary code is really cool. We also see here that in an aux module, we might be able to do more arbitrary sort of one-off hacks that also make Metasploit very, very helpful. There is another really cool module in Metasploit that I want to explore with you a little bit, and that is called the no-ops module. There's no-ops and an encoder module. So we have the idea of a no-ops sled, and as you see in that first bullet point, it says generates no operation instruction used for blocking out buffers. What in the world does that mean? Well, what we're doing with that is what we want to do is we want to pad or slide the execution flow that we're running into the shell code. And so we have these instructions that do nothing but advance the instruction pointer as we look at line by line of code, making it easier to land on the payload. So what we do with the no-ops module in Metasploit is generate what's called a no-ops sled of a specific size, and then that sled can be used to do padding, fill buffers for an exploit. And what we're trying to do with the no-ops sled is make what we are doing compatible with various operating systems, etc. And then when we have encoder modules, what we do is we encode payloads. Again, we're trying to make it compatible under a variety of situations. With the encoder module, this helps you avoid antivirus detection, IDS detection. And so we have obfuscation that's available to hide the true nature of the exploit, bypassing signature detection, polymorphism, where each time the payload is generated, the encoder modifies the appearance of it just a little bit. What we're trying to do is avoid the likelihood of detection. We also have a couple of other modules we want to talk about with Metasploit. One is the evasion and post-exploitation module. So evasion allows us to get around IDSs, IPSs, and endpoint protection. And post-exploitation is once we've compromised the system, then we can use these to gain further access into the system. All right, and now we look at some AI-powered tools. Nebula is a nice one to find vulnerabilities. Deep Exploit, another really good tool to find vulnerabilities and run exploits. And then we move into the idea of buffer overflow. Buffer overflow is one of the most useful techniques to do a variety of attacks on a system. So this section is going to get a little bit technical, but I'm going to slow down. We're going to talk about what it does. I also want to run an advertisement for you. And no, I don't want you to like and subscribe. What I want to advertise is the lab. So in the first lab for Module 6, we have a very well-written buffer overflow lab. And you'll see that it's based upon this. So if you go through this and some of it is a little bit hazy or fuzzy, you want to go back and understand it, go through the lab and then go back through this module again. Let's have a look and see what we're going to be talking about in this section. First of all, what is a buffer? When you run a binary, so it's an executable, some type of program that runs, it requires two major items. Number one is CPU access. So your CPU is going to be running clock cycles, taking information off the bus and processing it, making use of its various caches, and eventually sending those commands and etc. around the MOBO, the motherboard, to execute whatever you want and software, etc. So the CPU. And where is that CPU going to be running that code from? RAM. Random access memory. And so if right now you're looking at this on a computer, you may have other tabs open. I mean, I had you go over to XKCD, so you may have other apps open. All of that you see on that screen is running in RAM through your CPU. So let's have a look over here what the problem can be. When the app is written, it is allocated only a certain location, set of locations in RAM. If it goes beyond its allocated location, we have a buffer overflow. And a buffer overflows happen because, if you look at all these bullet points down here, It was programmed bad. There we go. Just summarize it, right? They didn't do bounds checking. They had old versions of things. They had bad programming practices. If you look over here, improper memory allocation, insufficient sanitation. So they did a bad job. We have this thing called the CI/CD pipeline. The CI/CD pipeline has a constant delivery loop that we use to keep software current and fresh. And that needs to be paired with a DevSecOps operation that will make sure that every part of code that you deliver is secure. If you don't have that, then it's very likely you'll put out bad code. All right, so we're going to slow down and we're going to make our way through and talk about buffer overflow. All right, the first thing we want to talk about with buffer overflow is stack-based overflow. There are two major types we'll talk about, is stack-based buffer overflow and heap-based buffer overflow. So with stack-based buffer overflow, we have, first of all, I want to show you how we put something on the stack. So this is a little piece of code written in C. And if you look at this, we have local variables and some function arguments. We have a stack function. We have a couple of variables, A and B. And we have values 10 and 20. That are passed into the stack function, and then those are pushed onto the stack when the function is called. And so when stack function is called, the space for those local variables and the function arguments are allocated on the stack. So we allocate that space. And then after the function returns, something very important, the space is freed and another process or application can make use of that space. So with a stack-based buffer overflow, this is going to happen when a program writes more data to the buffer that's located on the stack than what's actually allocated for that buffer. So what the stack is a contiguous space in memory that we use to organize data. What's this data? Well, it's associated with things like function calls, function parameters, local function variables, management information for that app. And so when a program writes more data to a buffer, little spot on that memory, it almost always is going to corrupt the adjacent data on the stack. And so if it was triggered by mistake, let's say that I'm running an app and there's a buffer overflow. Oops, hate when that happens. It can take that program and just crash it or make it operate incorrectly or look weird or do something weird. A stack-based buffer overflow is a buffer overflow that can be triggered also. And so what we want to do is, in the case of attack, is cause that to happen in a way such that we can take control of that buffer space. One of the things you're going to see quite a lot in here is you're going to see a lot of different buffers like EIP, the extended stack pointer, and EBP, the extended base pointer, and EIP, extended instruction pointer. So you're going to see a lot of these as we go through and look at different types of buffer overflows. That's stack, right? So for stack, one other thing I didn't mention in the second bullet point is when you use a push operation, we store data on the stack. We use a pop operation to take data off the stack. A funny thing is, as I remember, back in the old days of the Commodore 64, do you remember? Did you ever? Yeah, some of you've had those before back in the old days. Very old computer, and the thing that got my young mind it just sounded so funny. It was called peek and poke to move information off and on the stack. All right, let's look at heap-based buffer overflow. And one of the things about heap that makes it different than stack is heap is dynamically allocated. And so what you'll see is we use a malloc to allocate it. So I have a little piece of code I want to show you here. It's hard to see this, but what we're doing with this is we have a malloc we're using to allocate memory on the heap, or allocating enough space in this little code snippet that I have here for 5 integers. It's an array that we're putting on there. And then we do a null check. We want to check to see if malloc returns a null, which would indicate that the memory allocation did not work. So we need to check for that. And then we store the data in multiples of 10 into this heap-based array. And then guess what we do when we're finished? Right at the bottom, in that section on the bottom of the code, we do memory deallocation. So after using that allocated memory, we free it, and it's called we deallocate it to prevent memory leaks. So this is, again, just using C programming. So let's talk about what happens when we overflow the heap. And so what we have here is, again, we see malloc used quite a lot here. And we can exploit a heap-based buffer overflow in various different manners. We corrupt the data in specific ways that cause the application to override its internal structures, like, for instance, linked list pointers. That would be one of the ones that we do. So we have a canonical heap overflow technique that will also overwrite dynamic memory allocation linkage. In this case, we see as in malloc metadata. And so what happens is we overwrite the function pointer and we have a heap-based buffer overflow. So that's what we do, as you see in this slide, with heap-based. So stack-based and heap-based buffer overflows are the two places where we go. And I put up a couple pieces of code that were friendly. The code showed you how to basically put information onto the stack or put information onto the heap. And they run well and they work. The code you see over here doesn't work. All right, so if you look at this, what we see on the left is we do a stack-based overflow. So we're not putting information on the stack in order to demonstrate it. No, we are overflowing the stack. And if you look at the very bottom, you see that GCC right there. What we're doing with GCC is we are using a compiler to run the C code. And you'll see in both cases for stack and heap-based that we overflow the buffer. And if you look at the heap-based, you'll see, I like to say at the bottom, look at that, all those A's, it's going, ah, I've been overflown. Right, so that's what we're doing. Those two are code examples. Make sure that you have a good look at that, make a note of it, so that if you see a code sample appear on the exam or a practice exam, you look for some of the structures that you'll see in these to realize which one is stack and which one is heap. All right, so now what we're going to do is we're going to go over the steps for buffer overflow. And those are starting with performing spiking, moving into fuzzing, identifying the offset, overriding the EIP register, identifying bad characters, identify the right module, then we generate shellcode and gain root access. So let me just give you some advice right here. You need to know these steps. Let me give you an example exam question. Here we go. Exam question. Fred, who is a developer at XYZ CEH Corp, and he is testing his code to see if it's vulnerable to exploitation. Which of the following is not required for buffer overflow? So here's one. Ready? Generate shellcode. Perform fuzzing. Execute shellcode. Identify bad characters. So execute shellcode is not on the list, right? It's not on the list. I mean, obviously you have to execute it, but it's not on the list. So therefore, you would choose execute shellcode because it's not on that list. So make sure you know this list. And now what we're going to do is we're just about to go into step-by-step how to do this. The screen grabs that you see on here are taken from the lab itself. But before we do that, I want to talk a little bit about other techniques. There are other techniques for buffer overflow. We're going to look at some of them a little bit later, like heap spring, and we already talked a little bit about using no-op sleds, and there are many techniques. But I tell you what, these steps that we have listed here are some of the best of the techniques in order to do buffer overflow. All right, let's get started. All right, the first thing we're going to be doing is we're going to do what is called spiking. So we're going to send these crafted TCP and UDP segments at the server that we have set up. So step one, we're going to establish a connection. I want you to see something very, very important here. We're using a really wonderful tool called Netcat. And what we're doing in the beginning, you'll see this when you run the lab with me, is this is called setting up a Netcat listener. And what it's doing is just going to wait there and listen. One of the most fun things that you get with a Netcat listener is when you are successful, in the end, it pops out a nice little prompt. It could be a prompt from Windows, if you're doing a Windows exploit, or it could be a prompt from a Linux terminal if you're doing a terminal exploit. And then you can do a who am I, and you can find out what level of access you had. That's really fun at the end of it. But meanwhile, it's going to sit there and wait for output from what you're doing on the other end. And then we're going to generate the spike templates and run the spiking. So what we're doing is we're throwing all kinds of data. There are two types of stress tests that we're going to run. The first one is spiking, and the next one is fuzzing. And so that's what we're doing here. We're running spiking. Now, I want you to also have a look at the app on the right. This is going to be our major tool that gives us insight at the byte level, at the bit level, as to what's going on with the app itself. And if you look at the bottom right-hand corner, you'll see it says paused. Why? Because you blew it up. You spiked it so much that you overflowed one or more registers, and now the program stopped. We can go through here and look at the code. And we're going to do a little bit of an examination as to the output of Immunity Debugger as we get a little bit further in past fuzzing. So fuzzing, we use a nice little tool, little Python script called FuzzPy, and we run that. We send a huge amount of data, and in this case, what we're trying to do is extract the location of the EIP register. So before we go on, let me talk about overall what we're doing in the beginning. We have several different steps that we need to do to figure out where we are. Let me tell you why. All right, so I have an application. The application is running. It's going into allocated space, but where is that? What module is running? What function is running? If you look at how RAM is put together, it's like a city. It's like Los Angeles. And you have in some block in Los Angeles, everything went wrong, right? That is the buffer overflow. Where precisely is that located? We need to find that, right? The whole city of Los Angeles, which is now an app, crashed because of that one block. All right, let's find where that block is located, and let's find the entrance and exit to that. Let's characterize it so that we can run our own shell code in that area. So you have a lot of program to look at, and we're trying to characterize where in that program, where in RAM, what module that the buffer overflow takes place, so we can take advantage of that. So that's what we're doing with fuzzing and spiking, and we have a few more steps that we're going to use for this. All right, let's have a look at this one. What we're doing here is we're making use of the fuzzing, and I want to kind of zoom in on here and talk a little bit about what we're seeing here, because that is very helpful. What we're doing with this is we are looking at the disassembly window on the far left. So what we do is we took the app and we broke it down into all of its instructions and disassembled it, right? So this is the code. We have a server that we're running in the background called vulnserver.exe, and it has machine instructions that the CPU is running, and we have move EAX, DWORD, PTR. There's a lot of different, this is actually, I think we highlighted that there. This is the current instruction that's being run by the CPU. And then if you look at the top right-hand corner, that is the register window, and that gives us the current values of the CPU registers, like EIP, which is for your instruction pointers, like ESP, which is for your stack pointers, like EBP, which is for base pointers. And EIP really, in this case, is crucial because it indicates the next instruction that the CPU is going to execute. So in this case, what we're doing with fuzzing is we're trying to overwrite EIP to redirect code execution. Well, eventually we'll do that. What we want to do is run our malicious code there. Let's go to the bottom left-hand corner first. That's the hex dump. It shows the raw memory contents at the specific address where we are. We can see the data that was sent during fuzzing and how it's handled by the program. And you can also see ASCII characters like run, complete. I don't know if you can see, that's kind of, you have to zoom in on it. And on, MOHN. These are kind of artifacts of the fuzzing process. What it's doing is it's showing us that input data has been injected into memory. And then finally, at the bottom panel, we have the status bar, and it tells us that there was an access violation when reading 000, etc., E5, right? So it gives us a location and attempted to read that memory, and it shouldn't have attempted to read that memory. This is because during fuzzing, we had malformed input that went into that caused a program to crash. And so what's this all about? Well, why would we do this? Well, because of that location in that module, it suggests that there is a potential vulnerability that we can exploit. All right, let's look at the next one. All right, so now if you look at this one, what we're doing is we're going to identify the offset. We're using a couple different modules, pattern create and pattern offset. What am I doing identifying the offset? So again, in Immunity Debugger, we see on the right-hand side that there's been a buffer overflow overriding the EIP in the Vuln Server XE program, and we see random bytes are now in that register. They're random. So what we want to do is find the exact position. That exact position is the offset in the input where the buffer overflow happened. And that buffer overflow caused that EIP register to be overwritten. And so this is going to be crucial to have that exact location. So the first one we have is pattern create that you see in that little gray box at the upper left-hand corner. And this is actually a Ruby tool in Metasploit. So we're going to be using Metasploit. In fact, if you look at there's a big highlight on the far left-hand side there. That is Metasploit, and we're using pattern create also. And so pattern create, what we're going to do is we're going to use this as a way to put input into that vulnerable program. And so it'll cause the program to crash, override the EIP, but what we want is to find the exact sequence of bytes, and then once we find that, we can use pattern offset to find the exact location. And if you look at the window on the right, you'll see that the terminal output says that an exact match was found at 2003. So on the 2003rd byte of the input pattern, that is where the buffer overflow starts to overwrite the EIP. And the reason this matters is because when we identify the offset as the attacker, we can then craft an exploit, and knowing the precise location, we can precisely control that EIP register and run our malicious shellcode. So that's what we're trying to do. We have to find out exactly where to do it. All right, let's have a look at this one where we are going to overwrite the EIP register with our malicious shellcode. So let's have a look here. We see that the EIP register, if you look at that number 42 that you see here, it's been successfully written by a value 42424242 or something like that. And that actually corresponds to ASCII B, the letter B, value 66, which is 0x42 in hexadecimal. So this is a very common technique that we use for buffer overflow exploitation. What we're trying to do is to test whether the attacker, in this case us, whether or not we have control over the EIP. And so we have a really nice script here for us at the far left side. That little window, the black window on the left, is a script called overwrite.py. It's a little Python script that's used to send something that we specifically craft into the vulnerable program, which in our lab is vulnserver.exe. And so the shellcode will have a variable that has 2003 in it, A characters to fill the buffer, and then followed by B characters. And those B characters are going to overwrite the EIP. So that's what we're doing in an immunity debugger on the far right. You can see this happened, and it's paused, which means that it crashed. Bad characters. So what is this bad characters? It says that we need to identify bad characters. Well, let's talk about bad characters. They are specific values. They're byte values that can cause issues when we're running our shellcode. And so let's say we're running our shellcode and it discovers a character in there and it stops the shellcode from running. I'm not going to gain access to that system. So what I want to do is identify which characters are bad. So there could be anything that would like terminate the code or prematurely corrupt the way the code runs, make the code non-functional, stuff like that. So we need to identify those bad characters. And so an example, if you look at the bottom left-hand corner of the slide here, an example is that /x00, which is often used to identify the end of a string when you're programming in C. So what we're doing is we want to identify those. So when we inject into the EIP register, nothing will stop us from our attack, right? So we're going to be looking at byte values from X00 all the way to XFF to find bad characters. So we're going to go through that, and you can see Immunity Debugger on the right-hand side has shown that, again, we cause it to stop. We have a value of 414141, etc., which is a bunch of A's. And so what we have is raw memory, the contents of it, and we're able to identify anything that would stop our code from running, including bad characters. All right, so now that we know what might stop our shellcode from running, we need to know where exactly to run the shellcode. And so that's where we're going to get to the next step here, which is identifying the right module. So we want to have the correct module. And so very important to do, find that module within the target application that does not have things that might stop my code from running. Like for instance, DEP, data execution prevention, or ASLR, which is address space layout randomization. If I have a module that's protecting memory from my hack, that's not going to be very good for me. So we find the module with those protections, and then we can avoid them. So we're using a very good tool on the bottom right-hand corner called MonaPy, and it helps us to scan the module in that application and make sure we know exactly where the right module is. And then once the right module has been identified, then we can find a very good, or I guess you could say suitable instruction within that module to hijack the program's execution flow. So whenever we're doing a buffer overflow exploit, what we're going to look for is a JMP ESP. So JMP ESP instruction, that's what we're looking for. You can see this on the slide too, which can redirect the execution of our shellcode. So that's what we're really looking for. And then once we identify this location, we're ready for the exploit. All right, so let's have a look at this one. This is where we're going to try to take what we've found and extract that information. So we see there's a breakpoint that's been established, an address. If you look at, it's hard to see on this slide, but it's actually 0x, starts with a 26 and ends with an AF. You'll see this when you're in the lab. And there's a function that's in a dynamic link library called ESF function, func.dll. Either way, this is the address of a JMP ESP instruction, or something like that I could use to redirect the execution flow of my shell code. And then we highlight that. We have a nice little Python script we talked about before called JUMPy, JUMP.py, that we use to exploit that vulnerability on the target computer. And so it's going to go to the offset of 2003, go to the appropriate address, And then we now have the ability to control the flow execution of the program. And so this is right towards the end of the buffer overflow process. We're almost ready to run the hack. All right, so now we go over to MSF Venom. And so with MSF Venom, this is where we're going to finish the attack. So we're using Metasploit, MSF Venom. Love MSF Venom, and we use it for a lot of things in this class. You'll see that over and over again. And this is going to be where we generate the shellcode. It's a little payload that's going to be injected into the vulnerable application. What we're going to do with it is create what's called a reverse shell, and that way we can gain control of that system. And so if you look on the right side, you'll see that we have that reverse shell connecting to the machine. We have lhost equal to 10.10.113 and port 4444. That's 4 4s, right? That's what we're trying to do because we have a Netcat listener already waiting for that. And then we take that generated shellcode, we copy it and inject it into the target application, replacing the overwritten EIP register value with the address that points to the start of the shellcode. And when the program execution reaches that specific point, then it'll execute the shellcode, opening a reverse shell back to us, to the attacker. And then what'll happen, if you look at the bottom right-hand corner, this is the great part. The bottom right-hand corner, Netcat listener then gives us that command prompt from that Windows system. And then from there, we can type in commands. The first command that you want to type in this situation is, who am I? And it tells you, you are an administrator. Nice, this means it happened. Now, we talked about quite a lot in that section. If there's stuff that you didn't understand, do the lab. And when you go over it a couple of times, it'll all make sense. All right, the next thing we want to talk about is ROP, a ROP attack. So what we're doing here is we're still talking about taking advantage of gaining access through low-level means. And this one is called oriented programming. That's what our ROP attack is. And it's a nice technique. It's a way to exploit, hijack a piece of code after you exploit a buffer overflow vulnerability. And so what you do is gain control of the call stack of the app, execute existing code snippets. They're already there. They already work within the program, within the shared libraries. And these code snippets that are already there are called gadgets. What is a gadget? It's a small sequence of instructions that usually end with, if you look at this, at the code on the right side, look at what it ends with, RET. See that RET? Or return instruction. So what happens is you could take these gadgets and chain them into your own attack. So they're supposed to run in a certain sequence, but you just change the sequence in which they run in order to run the attack. So you use a sequence of gadgets, and what you do is you create a new program, essentially. It's like taking Legos, right? Let's say the Legos are a boat, and all the Legos are the gadgets. And then we rearrange those, and then we have an airplane. So it's the same instructions, it's just in a different format now. So that is actually a pretty cool little methodology for attack. The next one we're going to look at is called heap spraying. So if you look at this slide over here, what you'll see is that we have a couple of different means of defending an app that I was talking about, ASLR and DEP. We want to bypass those. And so what we want to do is free space in memory with multiple copies of malicious code. So if you look at what we have here, we have before heap spraying, we have free space, we have allocated space. And now on the right side, we have an injected payload, and we've taken up that free space. Very interesting stuff. So what DEP is data execution prevention. What ASLR is address, space, layout, randomization, and these help to protect apps. So what we're going to do is flood that free space and put in our own payload. and we have tools that can help out with that. All right, the next one we're looking at then is JIT spraying, and this is just in time. And so this is a technique where an attacker uses the just in time compiler. Where would you find a just in time compiler? Usually you're going to find that in a browser. And then what you're going to do is you're going to inject and then execute arbitrary code. Again, arbitrary code. Love those words as an attacker. And you're going to be able to run that. So the just-in-time compiler will translate that JavaScript that you've written for that app into machine code at runtime. And then we explain that process to put malicious code into memory. So number one, we trigger the compiler. And then number two, we do the memory allocation. And that helps us to bypass those security precautions that are there. And the reason it's so effective is because we're able to bypass security and because of the wide attack surface. It's time for AI. All right, so many different techniques, many different tools again. So now let's walk over here and talk about what we're doing using AI. So in this case, if you have used MSF Venom a few times before, you probably realize there are a lot of things you can do with MSF Venom and a lot of different variables that you can run with MSF Venom. You may not remember every single possible way to use MSF Venom, but guess what? Your AI does. And so you can say use MSF Venom to create a payload with host 10.10.113 and L port 444. Probably you mean 4444. No, we're doing just 3 4s in this case. And then from there, we have a look at this one where we say use the MSF console to start a listener with host 10.10.113 and port 444. So now we start a listener and it sets up that NCAT listener. And then once it sets up that listener, then we're able to proceed with the rest of the code. And we're not going to go into all the rest of the steps that we did before, but as you can see, we can use Shell GPT to make this happen. All right, so now it's time to get into a little bit more of Active Directory. And this takes us into the idea that admin tools are hacker tools. Over here on the slide, you see a very cool tool called Bloodhound. What you use Bloodhound to do is to characterize Active Directory. You can see it's got a nice little diagram here that shows how Active Directory is connected, what it's doing, and so on. And one of the things that it will do is identify vulnerable paths. So we can use Bloodhound on Active Directory to get that map and then find, even for complex, in fact, Bloodhound is very good. One of the things that I've been able to do in terms of consulting and work is work with 2 major structures that are extremely complex. And one of those would be a university. And universities are crazy because you have all of these different colleges, and within the colleges you have all these different areas, and everybody wants their own power. They want to control their own part of Active Directory. So you have to write special rules and so on, and it gets very, very complicated. The other one that I've worked with before is military bases. Again, they are very huge and they have a variety of needs in terms of directory structure. Using something like Bloodhound helps somebody like me to make sure that I understand the flow of Active Directory and find areas where there are potential issues. But again, the attacker can use the same tool. All right, so now let's have another look at a tool. This one is actually another nice admin tool. Like I was saying, admin tools are hacker tools. What we're doing with this one called PowerView is making use of various Active Directory based PowerShell commands to get more information on Active Directory. So we can, for instance, get domain policy or get properties from the domain, do some enumeration of Active Directory. It's a collection of tools that is extremely useful for characterizing Active Directory and hacking Active Directory. All right, next thing we look at then is a couple of other tools for AD enumeration. We're finding existing domain computers. Let's actually have a look at that. Let's go over here to the left-hand side here and look at some of these commands. If you're running Windows right now, you can right-click on the Start icon on the bottom left-hand corner of your screen and go to PowerShell with admin, and then give it the admin login, and then type in get-net computer. If you're connected on the network, it'll dump out information about the system. Over here, if you're on Active Directory, which I would imagine not all of you in this class would be, but you could do a get-net group, and it tells you the groups with which you are associated. And then I want to have a look at this one over here, where we're doing a get-net GPO. That's a group policy object. And then that vertical is a pipe. We're going to pipe that into a get object ACL and resolve GUIDs, the globally unique IDs, and then give it the specifics that we're looking for. And it takes all the GUIDs for those objects and lists them out for us. So these are just some basic examinations of how we can use PowerShell to find out information and enumerate the domain of a given network. All right, next we look at buffer overflow detection tools, because we don't want people like you or people like me running buffer overflow. So what we want to do is make sure that that is not possible. So a few tools that we look at over here, we have Veracode, Fault Finder, Qwant, Splint. Over here is Olidog. What these tools do is they look at your code, make sure that it's not vulnerable to a buffer overflow. We can also have a look at defending against buffer overflows. All right, I want to tell you a little bit here. This is one of the areas that, and there are going to be many of them in this class, that get deep into the dev side of things, the programming side of things. And so usually when we talk about items that are outside of operations, so for instance, I need to tell my developers to do, what I will do is overview these. So let's have a look at that over here. And so in operations, one of the things we can do is regularly patch. Oh yeah, okay. Perform code inspection manually. That's not something I can do in operations. This is what I'm going to say, hey, dev team, I want you to do that and make sure that it meets certain criteria. Hey, what criteria? Well, let's go back and look at our DevSecOps. Let's look at how we secure our code, and that's going to be the criteria. Let's look over here at the left-hand side. And again, this is going to be fairly arbitrary depending on what your company does, but develop programs following secure coding practices. Again, that's fairly arbitrary. So here is what I want you to do. I want you to take all of these, and maybe this is going to be next year, and you're going to be working on a team, and I want you to refer back to these in your courseware and ask your dev team if they have that set up appropriately. But what you can do in the ops side of things is make sure that every aspect of that code environment has the latest patches and updates, so at least that environment is friendly to very good operating code. Okay, so we are in the second learning objective. In this case, what we're doing is we're going to be using different techniques to do privilege escalation and gain admin privileges. So let's have a look at this. All right, the first thing we're going to be looking at is the differences in privilege escalation. There are two types of privilege escalation. One is horizontal, and the other one is vertical. So let's look at horizontal first. So let's say that you find your way into a system and you only have a user account. And with a user account, you can't do much, but you're able to find another user account. Let's say this other user account is a DBA or DBO, which is a database administrator or a database owner. And maybe now I can hack through that database server since I've horizontally expanded my reach. But most privilege escalation is vertical privilege escalation. What they're looking to do is move from a user account to a root account or an admin account and move up, going for root. That is vertical privilege escalation. All right, so for privilege escalation, one of the methods for doing privilege escalations is to do DLL hijacking. So let's have a look at this, and while we're looking at it, I want to talk to you just a little bit about what a DLL is. A DLL stands for Dynamic Link Library. What is a dynamic link library? Well, it's a library that is dynamically linked. I'm just joking. I'll tell you what it is. Imagine that you're putting together a program, and this program has a horizontal scroll bar and a vertical scroll bar. Imagine also that this program has a file menu, and it has an edit menu and a help menu. And let's say that this is just one of dozens of apps that you're going to be working on throughout the year. Do you really want to put together the code for a horizontal scroll bar every time you create a new app and create a new set of code for the file menu, etc.? Rather, what you do is you have a dynamic link library. And so when it's time to use a horizontal scroll bar, you just reference hscroll or vscroll or f_menu or whatever, and you reference those in the library. And now I can write all those dozens or whatever pieces of code without having to rewrite all these. I just put them into a library and I put a call out to it. Okay, so what if I, as an attacker, can get a hold of that library, and when that app calls hscroll or whatever, it also is able to make use of my malicious code. So that's what we're talking about, privilege escalation using DLLs. There's a lot of other types of hacks we can do with DLLs. So what the user installs an application, but the application, when it installs with the DLLs that the attacker already put in that library. And so something like Spartacus or Powersploit can be used by an attacker in order to use a DLL to hijack the system. Right, so that's one of the things we can do. But there are quite a lot of other techniques to gain privilege escalation or to do privilege escalation. And one of the best places to find that is in the GHDB, the Google Hacking Database. So if you look at the Google Hacking Database and you go to that little spider in the upper left-hand corner and you do a little search, you might find privilege exploits that you might be able to run. All right, so let's have a look then at the next type of exploit. It's really the same thing, except for it's on a Mac, and it's called a dylib instead of a DLL. Let's have a look at it. Same exact thing. We have a user, they're running an app, it's been, the library, the dylibs have been exploited by an attacker, and so now malicious code can be used to gain privileged access through the Mac. All right, so the next thing we look at then is a couple of vulnerabilities called Spectre and Meltdown. So is it possible that your computer could be vulnerable to these vulnerabilities? The answer is yes, it is, period. That's it. Your computer is vulnerable. What it does is your CPU, let's say I'm a CPU. I'm a CPU, and there's the bus to my right, and every clock cycle, so let's say you have a CPU that's running at 1.5 gigahertz. So 1.5 billion times a second, I'm turning to the bus and I'm getting an instruction and I'm processing the instruction and then moving it on. Again, I turn to the bus, get an instruction, process it, and move it on. But now I turn to the bus and I get an instruction and I'm like, oh, you know what? 7,283 instructions from now, there are going to be 5 instructions that are going to tell me to do this. Whenever I see this instruction, 7,000 whatever instructions later, I get 5 instructions that I have to put together. So what I'm going to do is I'm going to take those 5 instructions and put them in a buffer and pre-stage them so that I can run them ahead. I'm doing what's called speculative execution. And what this does is one of the many tools that CPUs use to run faster. They know what's coming, they get ready for it, and they can run things even before they're told to do it. I don't care if it's an AMD, I don't care if it's an Intel, I don't care if it's an ARM, your CPU is vulnerable to Spectre and Meltdown. So if you look at the Spectre one here on the left, let me get my laser pointers are working here. So they can read adjacent memory locations and get unauthorized access, read kernel memory, etc. Web-based attacks using JavaScript are possible with Spectre. And over here on Meltdown, they can get unprivileged access, forcing an unprivileged process to read adjacent memory. And they can get private keys or credentials, etc. So right now, virtually every computer has that. In fact, your computer is probably running slower right now because it's patched. So another type of privilege escalation that you can do is using named pipe impersonation. Let's have a look over here and talk about what's happening here. So what a named pipe is it's a way for a client-server LAN application to talk between the server and the client. And so if you can impersonate a different client, then you can gain privileges. So what we do is we have what would have been legitimate communications, but instead what we do is we use various tools, and these, by the way, are in Metasploit. And a lot of the tools that we'll be using for post-exploitation in Metasploit will be using Get System for Windows. And so we use those tools in order to gain higher privileges. So there are many ways of doing this, and there are many different tools in Metasploit associated with that. So one of the things that we can do is make use of what are called unquoted service paths. And I want to say that in terms of services in general, there's a lot of potential low-hanging fruit to hack services because they can, in many cases, be misconfigured or they can be unprotected. So let's have a look here and see what we're doing with unquoted service paths. So if you look over here at the left here, that path to that service should be enclosed in quotation marks. And so what happens, it'll locate the binary through a specific path. But if it's unquoted, it'll make use of other means to find it, and the attacker can take advantage of that and insert their own code into that path. The next one, we have service object permissions. And so you can modify the attributes, so much so with the service object that you can even create new users. If you look at another one, this is a very interesting one. I believe it was for Windows Vista. And so for Windows Vista, Microsoft did something really cool. Back in the old days, if I was working with an organization and I was working with the desktop support team, and the desktop support team needed to image a huge number of desktops, or if I was working in the data center and I needed to image a huge number of servers, I would have to use something like Norton Ghost. And wow, we put together all kinds of really cool images with Norton Ghost. But as of Windows Vista, Microsoft started shipping Windows in the form of an image. And they provided us with imaging tools. And what did I say about tools for system administration? They're also hacker tools. So in this case, let's have a look over here and talk a little bit about this. When you use the imaging tools, let's say I'm imaging different departments, different locations, and let's have a look over here and you'll see that I might be putting user information, password information, folder information into the settings of this file right here, onattend.xml. And very likely, your onattend.xml will be located in Windows System 32 sysprep. There's actually an app called sysprep that pops up and helps you work with imaging those systems. And so if I'm an attacker, that's another thing I'm going to be looking for. And maybe, just perhaps, I can find the information on admin accounts in the onattend.xml and then gain extra privileges. The next thing we look at then is pivoting. So what happens is, let's say that I hack a machine and I'm on that machine and I look around the network and yeah, there's nothing here that I really want. And that's what we see in this first illustration over here. So what I'm doing is I'm using Metasploit to do a little scan. And I look around and I say, you know what? I don't want to be here. I want to be somewhere else. I want to be on a different subnet. So what I'm going to do is pivot from that machine to another machine, from that subnet to another subnet. And so what we see here is we're going to go to number 2. We're going to set up new routing rules. So in other words, I'm telling it, hey, take my packets and move them to the other network. Now on that other subnet, I can scan for live systems and then run another hack in step number 4 and exploit vulnerable services. So pivoting is going from one subnet to another. The next thing we look at is also pretty cool, and that is relaying. And so let's say that I have some exploit that's on a machine and I want to be able to get to that exploit. What I need to do is I need to relay my commands into that machine. By the way, this is something that I've done for years. Whenever I host, let's say you host a web service in your home and you want, if somebody does www. whatever, you want to relay that information into your internal web server, this is how you do it. So let's have a look at this. First thing we're going to do, as you see here, is we're going to set up what are called forwarding rules for specific ports. So in this case, we're doing port 80, port 22, port 45, 445. So that'll give us web services. That'll give us the ability to get a prompt and a terminal window open and to get to shares on that system. And then if you look, this is the really cool thing about it. Now, in order to access those services, I just do a localhost colon and give it the port I set up. So that is going to be a relaying. Earlier in a previous module, I believe it was module 3 or so, we're talking about NFS. And NFS is where we can mount services on a Linux box. Misconfigured NFS will also allow you to hack NFS. Let's have a look over here. So what we're doing here in this case is the first thing we want to do is find out if NFS is running on the system. And over here on the left-hand side, what you'll see is I'm checking that out with a nice nmap command. And notice I'm doing SV for service, and I'm finding what services are running. Sure enough, port 2049er, I have NFS. And since it is misconfigured, what I can do is I can establish a remote connection and SSH into that box through NFS. That's just one of the many hacks that you can do through NFS if it's improperly configured. And we'll see this also when we get to the lab in the Module 6 lab. All right, next thing we look at then is UAC. You try to install a program on your Windows box. And this little thing pops up, beep, it makes a little beep. It's the UAC. What the UAC is user account control. And the purpose of UAC is to make sure that a user level account doesn't have admin access to things like installing apps and many other things. So you can actually bypass UAC. So let's have a look at what we're doing there. So over here on the left-hand side, we're using Metasploit. And in using Metasploit, we're setting the target, running the exploit. And down here, you see the interpreter session is opened, and then it's cleaning up the registry. And down here, we have a nice little Windows prompt. What we did is we used Metasploit to bypass UAC. And another one, again, using Metasploit, is we're doing the same thing through the UAC, but in this case, we're using memory injection. So Metasploit is our major tool, and we can't go through and explain every step right now, but you'll see this when we get to the lab. And then if you look at these examples, we have several other examples of using Metasploit. One is through the FOD helper registry key. Another one is through the event viewer registry key. And the last one is through COM handler hijacking. So these are just various ways that we can what's called abuse UAC and gain extra privileges on that system. All right, let's look at a computer system. Imagine a computer system. It's turned off. You turn it on. You want access. You log in. You're finished. You log off. And then you turn it off. And those are the 4 actions on most computer systems where you can execute a script. So if you as an attacker can gain access to scripting in any of those 4 actions, turn on, log in, log off, and turn off, then you can have it execute your script. In fact, that can help you stay hacked on that computer system by looking at those login scripts. In fact, if you look at the slide, you'll see that it's a little bit different for different computer systems. If you look at Windows, it's the HKey current user environment user logon script. That's for a logon. If you look at a Mac, you have login scripts. If you look at network logins for Active Directory, making use of GPOs, there are RC scripts and RC local and common that you can put scripts in there. And of course, startup items that you can get to in root level privileges by putting stuff in there to run. And so scripting, very good place to do priv escalation. The next thing we look at then is going to be domain policy. So I don't know if you've ever done domain policy, but you go to Active Directory, you get a GPMC, Group Policy Management console open, and we're going to do this in labs, and you create a policy. And that policy will affect the entire domain. So anywhere you log on to that system, the policy hits you. So if I'm an attacker and I can affect that policy, then I can gain privileges in many different ways because of domain policy. So let's have a look over here and see a couple of ways of doing that. One is group policy modification. And so there is a scheduled task. The task scheduler will just run something when we put the scheduled time in, and I can use that to run a script or run a hack that would modify a group policy for me. And another one is domain trust modification. And a lot of times when I talk to students about these 2 methods, one of the issues is understanding what a trust is. A lot of people understand what group policy is, but we don't set up domains with special trusts as much as we used to. So let's talk a little bit about domain trust. So I'm going to bring my trusty pen here. And so this is a domain over here, right? Here is another domain over here. And they can be completely separate domains. And there's a special construct in terms of drawing that indicates how the trust works. So we draw an arrow. And I know an arrow seems pretty common, but there is a saying in Microsoft that helps understand how trusts work. And that saying is trusted arrowhead. So when I set up a domain, this one will be the trusting domain. And the one with the arrowhead will be the trusted domain. So trusted domain, trusting domain. Why is that important? Here we go. You take this arrowhead and you turn it on its side like that. Then you put a bar here, and the accounts are going to be in the trusted domain. So if I am an attacker, I have a user account over here. I want it to have access. Let's draw a folder. That's a file folder. See, that's a file folder. I know it looks like I stopped learning to draw in the 3rd grade, but it was actually the 4th grade, okay? So this account now, through this trust, has access to resources in this domain. So what I can do is if I can use the domain_trust utility, I can get information about trusted domains and the settings of those trusts and maybe abuse that trust and get an account in my realm or domain to get access to resources in a trusting domain. All right, so that's how that works. Let me erase all that. Here we go. And we'll keep on rolling. So using domain trusts, creating trusts, using group policy are all different ways of doing that. But yet there's another way we can do that, and that is through certificate services. When you install a Windows server, you have a choice to make it a domain controller. But another choice that you can do is to install Active Directory certificate services. And when you install Active Directory certificate services, you are essentially creating the root to a PKI. And with that PKI, you can distribute certificates, etc. But there's an interaction between the PKI and Active Directory. So let's have a look here and talk about how we can take advantage of that. So we have certificate services. We deploy it in the Active Directory environment to manage certificates for various purposes. Why would you have certificates? One of the reasons you have certificates is you might have a web server in your network. And in order to do HTTPS, you'll need to install a certificate on that web server. Why else would you have a certificate? Well, you may assign certificates to computer systems and network systems and so on, so that if they want to join the network or use the network, they have to present a certificate. And there are a myriad other reasons why you might want to use certificates. So if you don't do it right, you misconfigure your Active Directory certificate services templates, then they can be exploited. So if you look over here at the far left side here, there is a nice little app that'll help you with that exploit. And that's called Certipy. You run Certipy and it shows you the configuration of certificates. And then based upon that information, you might be able to dump that certificate information with a nice little cat command. And then you will find out whether or not this has been enabled or what type of authentication it uses and many other things. And based upon that information, then you might be able to use a certificate to gain extra privileges on Active Directory. All right, so you have a domain, you have a Windows computer system, you have a Linux and Macs on your network, and you want to defend against privilege escalation. What do? Let's have a look at these 10 items that we're going to do. Number one, we're going to restrict interactive login permissions. In other words, we want to make sure that only people who are authorized to log in right there at that system can do so. We also want to use the least privilege principle, making sure that we only give users the privilege that they need to do their job and nothing else. We also want to use MFA, multi-factor authentication. So not just a password. If you're in the military or you work for the United States government, you'll also use a CAC. It's a little card that you plug in. So you need two-factor authentication. Another one is run services as unprivileged accounts. So what you want to do is design your service account according to the specifications that Microsoft has set aside for service accounts. Number 5, you want to have privilege separation so that not one person has control over everything. Number 6, you want to encrypt your data. Number 7, you want to reduce the amount of code that runs at a particular level of privilege. Like for instance, you don't want all your code running ring 0, that's at kernel level, because if anything goes wrong, it crashes, or you don't want to have code that is only able to run with an administrator, and so you give people administrator access. Perform debugging using bounds checking, thoroughly test your applications, and patch and update your systems regularly so that you won't have a huge list of vulnerabilities, which is the updates that you're still looking for. And there's more. We also want to make sure that we have always notify on the UAC. We also want to make sure that we look at our paths and that they're quoted, and we look at our permissions, that we reduce privileges for users and groups. We only want admin privileges for a specific set of users, a specific set of groups. Too many times I've walked into situations on domains where too many people had admin privileges. I've seen this too many times. Whitelisting tools, what you want to do is make sure that only apps that should be running on the workstation or the server are whitelisted, and only those apps will run. Fully quoted paths, write protected directories,plists, read only on Macs, blocking unwanted utilities on all computer systems, and patching and updating your web servers. So these are some things you want to do to defend. Another thing we want to defend against is people hijacking DLLs and hijacking DILIBs. And we have a really cool tool that's very useful for this called Dependency Walker. Let's have a look over here. And if you look at this little screen down here, what will happen is you have an executable, and everything that depends on that executable, you will see. So if that executable depends on DLLs or other executables, you'll be able to see the tree that works for that executable. And then if you want to defend your DILIBs from being hijacked on your Mac, you can use DILIB Hijack Scanner. Very nice tool for your Mac. And lastly, for this section, we want to see what we can do to defend against Spectre and Meltdown vulnerabilities. Now, fortunately, for the most part, you are probably protected. You never know. You never know, though. So a good idea would be to use Inspector. This is one of the tools that we have as an availability to help with that. And then the other tool that you see there is Spectre Meltdown Checker. Both are very nice tools to help defend against Spectre and Meltdown. All right, so now we're in objective number 3. And in this objective, we're going to learn to hide what we are doing. So we have malicious programs that we've written, that we've found, we want to use on that system, and we want to gain remote access to that system, but we want to hide those programs. So at this point, what normally happens in the attack is the attacker who just has a foothold on that system will make a phone call, so to speak. What they're doing is they're calling back out through the network to the command and control services. So you may have a command and control server, C2 server in the cloud. You may have a C2 server on a system somewhere. What you're trying to do in this case is to get those malicious programs, get them ready and positioned to further the attack. So let's start with this first look at executing applications. So this is what we're going to be looking at in this section. We're going to be looking at keyloggers. Those are fun. We're going to be looking at backdoors and spyware. And we're going to be looking at crackers. We'll be able to crack passwords and stuff like that. And so the idea is that you are not there. You are not local. You are executing this remotely. So we need tools and techniques to execute code remotely. Let's kind of zoom in on this slide here and have a look at what we're doing. So we have a client exploitation. And so we might find vulnerabilities in the client that we can target. We might have services that we can execute and take control of or hijack. We also have 2 major subsystems in Windows. These subsystems are WMI and WinRIM. So WMI is an entire large API with background low-level control access for everything for Windows management. It is huge. So if you can make use of that remotely, that's very good. And also WinRIM. WinRIM is Microsoft's infrastructure for remote management for large corporations, big companies, big organizations that have thousands of desktops. Hey, they're using this backend to help control everything. All right, so what about the first one we talked about in that list earlier, keylogger? Keyloggers are amazing. If you look at this diagram here, you'll see one of the most important things I want you to see here is at the above where it says driver, that it's right above the kernel level. These are kernel level drivers. So when I'm typing on my keyboard, it's a very low level driver that's intercepting those keystrokes and turning them into letters and numbers, etc. And so an attacker can gather that information from keylogger injection, driver injection, kernel injection, and also using a physical keylogger. In fact, Metasploit, the baby universe of hacking, also has the ability to do keylogger attacks with keyscan start and key scan dump and log out keylogger. Those are some of the functions that we can use in Metasploit to take advantage of keylogging capabilities. Also, there is spyware. What is spyware? Well, it spies on you. So what it's going to do is it's going to watch what you do on your system and report back. How do we get spyware? Well, we get it by drive-by download. Do you know what a drive-by download is? We'll talk about how that works programmatically a little bit later in the class. But a drive-by download, you don't click on anything. All you have to do is drop by the page and boom, you have the download. Then we have anti-spyware and web browser vulnerabilities and software that you install and browser add-ons and cookies and many other ways that you can get spyware installed on your system. And I remember one time, this was a long time ago, I was on a Windows server, but I used the server as my workstation. And because of that, it didn't have a lot of applications on it. And I needed to burn a DVD or a CD or something like that. And I was in a hurry. I needed to go somewhere and be there on time. And so being in a hurry, I just did a quick search for the software and I downloaded it and installed it on my system and used it to start the DVD or CD burn. Then I left and I came back. I noticed that there was about 5, 6 different desktop shortcuts to applications that I'd never seen before. And I was fairly surprised. So what I did is I got a Sandbox, and it's called Sandbox IE. Sandbox IE is still around. And I ran the program in Sandbox IE, and I watched carefully as I stepped through it, and I realized that somebody had wrapped that program in a new installer, and they had added a section where you can opt out of installing all this grayware. And I didn't see that because I just hit next, 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 next. I was in such a hurry. And it is behaviors like that that can get people like me in trouble. So what we don't want to do is get spyware on our system. And those are the 5 different ways that can, or 6 different ways that can often happen. All right, so how do you defend against keyloggers? Well, to defend against keyloggers, there are a few things that you can do. Let's talk about physical keyloggers. You can get a little dongle and you plug it into the back of the computer, and the computer is angled into the cubicle where you can't see the back, or it's underneath the cubicle where you can't see the computer at all. So a lot of people never access the back of their PC. So somebody after hours could easily put in a physical dongle and plug the keyboard into there and then collect usernames and passwords and logons and chats and everything, and then later on come back and take that off and plug the keyboard back in and collect all that data. Or some of these physical keyloggers actually have Bluetooth and Wi-Fi capability, and they can be broadcasting that information. So the first one that I would say is to physically inspect all of your systems to make sure that there's no keylogger there. And yes, I've known organizations that have found keyloggers when they went to move their computer. So don't think it can't happen. Let's look at the rest of these. Over here on the far left is to do pop-up blockers and be aware of junk emails and install anti-spyware, firewalls, update and patch. So a lot of this is very similar, but there's another one that actually works really well in some cases, which is to use your on-screen keyboard. Sometimes that will be helpful in avoiding keyloggers. So these are some of the things that you can do to help get around keyloggers. And also we want to stop spyware, and it's similar stuff here, right? We want anti-spyware, anti-malware. We want to make sure we're using encrypted connections to websites. We want to make sure that we regularly check to see if something weird is going on. Number 6 there, look at Task Manager, find out what's going on. Then there are anti-spyware tools, keeping your system up to date, and a variety of items that you can see here in this list. All right, so one of the tools that attackers love, and by the way, they're very fun to use, these are called rootkits. Remember, root is administrative access for a Linux Unix box. So what a rootkit does is once it's installed, it disappears. So if I were to look at all my processes, I wouldn't see it. If I were to look at the behavior of my computer system, there would be hardly any sign that it was there. It blends in with everything, and it looks like it's not even there. So let's have a look over here at one of the rootkits out there. This is called a Fun Module rootkit, and it's an admin to kernel vulnerability that it takes advantage of. It uses a decon technique to disrupt the kernel security mechanisms, and then it slips in underneath where you can't even tell that it's there. So rootkits can be pretty bad, and there is a tool that I like for rootkit detection. If you use antivirus, anti-malware software, one of my beefs, one of the things I have against a lot of antivirus, anti-malware software is that when you want to do a boot level scan. Now let's zoom out again. I keep zooming out, but we'll zoom out one more time here. What is a boot level scan? Well, a rootkit will, once the operating system is running, it will hide out, inserting itself into normal looking processes so you can't find it. So what you need to do is find it before the operating system loads. So you'll need to do a boot level scan in order to find it. But a lot of antiviruses will only let you do a boot level scan if you go many levels deep or give special commands or so on, or if the software decides that you need a boot level scan. But I use Avast on some of my most used and busy systems because it just takes 3 clicks to get to a boot level scan, a boot time scan. And then you can download the latest definitions and then reboot your computer system, and it runs before the operating system to help you find rootkits. Another thing that you can do if you look over here at this list is make sure you have permissions correctly on your system. Make sure your systems are patched and updated. And number one, look at number one, reinstall everything, start from scratch. And sometimes you'll have to do that. Or you may have to reformat or delete partitions and bring it all back. So rootkits can cause big problems. So it's very important to defend against them if you can. All right, so now let's have a look at a very interesting area. And this is called NTFS ADS, or alternative data streams. And what it does is it allows an attacker to hide information. Let's have a look at how it works. It's actually fascinating. So if we look at this, I'm going to change the file names a little bit to try to make it a little bit more understandable if you've never dealt with NTFS alternative data streams. So if you look at this first step, it says to do notepad myfile.txt. Let's call that root file.txt, right? So it's a root file. And then we'll call where it says lion, we'll call that hidden1.txt. So we have root file colon hidden1.txt. When you hit enter, Notepad will open up. Now what I want you to do is grab 10 kilobytes of text and drop it in Notepad and save it. So we see hiddenfile1.txt, which is lion over here, has 10K of data in it. We did not put anything in root file, the my file, at all. It's got 0 bytes. So then I do the same thing for hidden2, drop 10 KB of data in it. So now I have 20 KB of data in forks of the root file, myfile.txt. If I were to have just that on my disk, and I do a dir and list out the files, I will see myfile.txt, or I would call it rootfile.txt, whatever you want to call it, and it would say 0 bytes, even though I know there is 20 kilobytes of data stored there. Wow, that's crazy. And it's pretty amazing. And if you want to see the 10K files that you created, just notepad to them, and they'll open up with the 10K. But why doesn't it show up on the system? That is a feature of NTFS. Why would NTFS have this feature? Apple, Macintosh, right? So if you want a Mac to run on a Windows system, it needs to be able to store the file metadata in a separate fork. And so to maintain that compliance, Microsoft has this NTFS feature. But let's see how we can use it as an attacker. So over here what we have is a Trojan that we want to sneak into the system. So I'm already on the system. I have a foothold. Now I have contacted my C2 server and I've downloaded this Trojan. So let's have a look over here. So it's 2 megabytes in size. It's a nice binary that I want to run on this system. And so what I'm going to do is I'm going to type. So type in Windows at the command line is like cat in Linux at the terminal. What it does is it dumps the content of the file onto the screen. But we're not going to let it dump it onto the screen. We're going to use the redirection operator that you see right here. And so we're going to type the contents of my Trojan hackware and dump that into what? readme.txt. No. We're going to go into the alternative data stream, trojan.exe. So I'm dumping it from an executable into an executable, but the other one is a different fork. So now what we want to do is use what's called mlink. So Microsoft has another feature that allows you to take volumes and mount them in folders and many other ways too. And mlink is one of the commands you can use to do that. So what we're going to do is we're going to create an executable called backdoor.exe. What's in it? Really nothing. It's virtually empty because what we're doing is we're mlinking it to trojan.exe. So if somebody scans the system, they might see, and by the way, I would not name it backdoor. I would probably name it something more innocuous like 2019 taxes or something like that. And then I type in backdoor or 2019 taxes.exe and it runs and it goes to that mlink and runs the trojan.exe. If somebody looks at this disk drive, they'll see the nice readme.txt, but there's an alternative data stream that won't show up at all. And that is where the attacker has hidden their Trojan executable. All right, next thing we want to look at then is defending against this. And one of the best things to do if you think that there's an alternative data stream on your system is to move or copy, especially copying that data to another partition, because then it strips all the different metadata from NTFS, and that's one way to get rid of it. But other than that, you need to make sure that you use a third-party integrity checker like the Tripwire File Integrity Checker or Gemmer or Stream Detector or Stream Armor, and then do scanning, real-time scanning to see what's going on in that system and keep your antivirus up to date. And I want to add this, is it's very likely that your free antivirus does not check for NTFS streams. Check into it and see. I mean, you can always take the antivirus that you use, go do a little lookup and find out if it defends against NTFS streams. All right, so there's another type of activity that an attacker is going to want to do. And they are going to want to hide data, and they're going to want to exfiltrate data. And one of the best ways to do that is to use steganography. When I think of steganography, I think, is that the study of stegosauruses? No, it's actually hiding stuff. Another thing that often happens is when we talk about steganography, a lot of people think that it is hiding stuff in images. But if you look here, we have at least 12 different ways of hiding data. All you have to think of is the cover where we're hiding the data is virtually any digital object, because there's always space even in compressed digital objects. So let's get a little bit deeper into steganography. The first thing that we're going to look at in terms of steganography is some of the tools that are available. There's one at the top, you see that little command line up there? That's called snow. And think of snow. What color is snow? It's white. And snow takes advantage of the white space. I mean, just look at this slide. How much of it is white space? I mean, literally probably 80% of this slide on the screen is white space. What if you had thousands of ones and zeros that were in white? You couldn't see them. They would blend in. So snow does that with documents. You also have image steganography and document steganography, making use of OpenStego and StegoStick, as you see here on this slide. So those are very nice tools. Also with steganography, we can make use of shell GPT to make steganography work for us in the most easy manner possible. Let's have a look at what we do with Shell GPT. So SGPT, _shell, and then perform steganography using StegHide, yet another tool, to hide text. My Swiss bank account number is 2323. Whoa, that's my Swiss bank account number too. That's nice. In cover.jpg image, file with password as 1234. And so we hit enter and it hides it, and bada boom, it pops up that JPEG, and you can't see it, but it's in there, right? We have used AI to help us make use of the tools to do stuff that might be difficult or take a lot of time and make it easy and fast. All right, so the next thing we use, we're going to use Shell GPT to do some more steganography. So you can leverage it to, and others. There are many other ways to do this. There's so much you can do with these LLMs. Use StegHide to extract hidden text in cover.jpg. So now we're extracting it with StegHide, and sure enough, I'm just so embarrassed that they are using my Swiss bank account on this class. Please only deposit, all right? Just only deposit. All right, so now we're gonna have a look at analyzing steganographically encoded messages. And so steganalysis is the process of reversing steganographically encoded images. And then, yes, you can do that. Yes, we have tools to help with that, but there are challenges doing this. And number one is that the information stream may or may not have encoded data. Let's say that there is, let's say, a 1 terabyte store of images, and the investigator has a hunch that there's something hidden in this 1 terabyte store of images. And let's say there are 230,000 images in the data store. And so we iterate through all of those, taking days or weeks. And finally we realize, oh, it's not there. You know what another way is you find the cover document and you find it is steganographically encoded. You invest time and effort and you decode it, only to find out that the message that you decoded is encrypted. So now you have to figure out how to decrypt it. So there are a lot of issues with doing this type of analysis. So we want to be very careful and not go off on rabbit trails, but we want to at least try. Okay, so let's look at some of the ways to attack steganography. So I want to actually have a look at this because we're going to see this also in module 20 when we're trying to crack encryption. So let's go have a look here. So the first one is stego only. What is stego only? Stego only is the stego object is available. And that's it. That's all I have to examine. I have no information about the algorithm or the message or anything. All I have is a stego. What's the next one? The next one is known stego. In this case, I have access to the stego algorithm. So I know what algorithm was used. And I have the cover medium, whether it's a document, an image, an MP3, a JPEG, or whatever, and the stego object. All those put together make known stego a little bit easier to work with. What about known message? I have access to the hidden message, and I have access to the stego object. I might be able to reverse engineer it and find out the algorithm and other items that were used. Known cover. I compare the stego object and the cover medium, and in that comparison, I might be able to find the stego message, the hidden message. Chosen message. So what we do for this one is we generate a stego object from a known message using specific tools. And I might have to iterate through tools. What am I doing as I iterate through these tools and knowing this message is I want to find out which one of these produces the same output, and that way I can get the steganographic algorithm that was used to originally encode it. The next one, so we have chosen message, and now we have chosen stego. So in this case, we have access to the Stego object and the Stego algorithm, and we can run through iterations to be able to find the message using those. And we have chi-square also. Now, if you look at chi-square or chi-square, depending on what school of thought you are from pronunciation-wise, and distinguished, statistical, and blind classifier, these are all ways of using probabilistic analysis against it. So what is it that we're looking for? Well, if you look at a steganographically encoded, let's say you have an image, often one of the ways that the image is encoded, or sometimes with audio, you'll have the LSB. LSB is the least significant bit. And so if you, let's have a quick look at how that works here. So with the least significant bit, what we're trying to do is we look at binary. So binary, let's say I have a binary number 1011010. So 1, 2, 3, 4, 5, 6, 7, 8. Hey, I got 8. That's nice. All right, so what we're going to do is the most significant bit is worth a value of 128, then 64, then 32, then 16, and then 8, 4, 2, and 1. So this bit over here that's only worth 1 is the least significant bit. And as such, it has the smallest effect overall on the image or whatever it is that we're examining. And since it has the smallest effect, what I can do is flip that bit periodically, and flipped bits in the correct order make a message, and I can end up putting a message into that cover medium by using the least significant bit. So what was I talking about? Statistical methods. So now what I do is I take, let's say I take hundreds of thousands of images over time, and I look at the average distribution of bits in an average image, and then I use a statistical model and look for variations in that distribution of that least significant bit. Now, it doesn't have to be LSB. There are many other ways that these images can be hidden. And so these statistical methods are actually pretty useful a lot of the time. All right, so another thing we can do is make use of tools. I like some of these tools. Stego Veritas, used that one before. I like Steganography Studio, a very good one. Virtual Steganographic Laboratory. Over here, we have ZSteg, yet another very good tool for looking at steganography and figuring out what's going on. Also, what we want to talk about is maintaining persistence. And so with maintaining persistence, if I have found my way onto that computer system, I have contacted my command and control services, I have hidden stuff on that system, maybe in alternative data streams, and I want to stay there. What if somebody reboots the computer? What if something happens that terminates my current connection? I want to maintain that persistence. That's what we're talking about. The first one that we want to look at for maintaining persistence is using sticky keys. Now, sticky keys is actually a pretty cool invention by Microsoft. The purpose is if there's somebody that has some type of physical disability and they just lean or press against a single key a few times, it'll pop up and ask you if you want to use sticky keys. And so if you look at the way this works, if you hit the shift key 5 times, a command prompt pops up. And what we're going to do in order to bypass and hack sticky keys is there's a module called sticky_keys in Metasploit. We can use the sticky keys feature and hide our attack on that system and maintain our presence. So we hit the shift key 5 times, command prompt opens, I have system level access. So instead of sticky keys taking you to something where it'll help somebody with disabilities, instead it helps the attacker. So we can use sticky keys for persistence. We can also use auto start. So that way when the system starts, it'll parse whatever's in auto start and it'll reload whatever tools, hacker tools that we have because it's in auto start. Yet another one we can do is what's called domain dominance. What domain are we talking about? We're talking about a Microsoft domain, Active Directory domain. So let's look at some of the techniques for domain dominance. The first one is remote code execution. After that, we go to abusing DPAPI, and then we go to malicious replication, skeleton key, golden ticket, and silver ticket. Let's start with remote code execution and DPAPI. So if you look over here, what we have is in this section here, what we're looking at is a user account. So you see here, it's a member of, and we have this account, a member of domain admins. And so if I'm a member of domain admins, I can use a CLI, and whatever I type will have admin privileges. We'll talk a little bit more about that as we get deeper into the class. The other one is DPAPI. DPAPI is a nice little tool that Microsoft put together to help actually protect the domain and the computer system. But what we can do is we can decrypt DPAPI protected files. And as you can see, we can use Mimikatz to abuse DPAPI. And if we can do that, we might be able to grab the master key from the domain controller. If we have the master key from the domain controller, then domain dominance is in our hands. The next thing we look at then is a skeleton key attack and malicious replication. Let's talk about replication. When you have a Microsoft domain, you have a series of domain controllers, and let's say that there are 5 domain controllers in a small business, and I'm a system administrator and I update someone's account. Those updated account attributes need to be replicated to all the other domain controllers so that they all have the same domain database. And that replication is happening all the time. So what I can do with malicious replication is create an exact copy of all that user data, all those attributes in Active Directory for even accounts like KRBTGT, which is a very low-level account in Active Directory. Mimikatz is our tool for that. The next one that we look at then is a skeleton key attack. With a skeleton key attack, we have malware that we're going to take some false credentials, inject those into domain controllers, and then have a backdoor password to that domain controller that is memory resident. And so again, Mimikatz is used for that. I was mentioning a little bit earlier that for a lot of Active Directory attacks, Mimikatz is the tool that is often used. The next thing we look at then is the golden ticket. So we have a golden ticket and a silver ticket, 2 of those. The golden ticket is the one that is so good that no one will even know that there's an attack happening. So what happens is the attacker is going to gather the domain name, the SID, and then they're going to impersonate a user. Then we come over here and they steal the KBTGT, the KRBTGT password hash. Now, there's a problem here, is that somebody has configured Active Directory improperly to even have this able to happen, because then the attacker can send a forged TGS request, that ticket granting service, and then they get a response, and then they're able now with, it's really considered a regular account on Active Directory with impunity. With that forged TGS ticket, they're able to go anywhere they want all the time on the network, and it looks like a good account. Again, what tool do you think we're going to use to do this? Yes, we're going to be using Mimikatz. And then the next one we have is a silver ticket. Not quite as good as a golden ticket. Just like an ounce of silver is not quite as good as an ounce of gold. But this one is another post-ex technique that we use to steal credentials and then create a fake Kerberos ticket that gives us a TGS ticket. And so you have to already have access to credentials that are from that local service account on the SAM, and then you create a forged Kerberos ticket. And this gives you less access than the golden ticket. And so that's why it's called a silver ticket. Another one is the admin SD holder. If you look at this slide, you see the admin SD holder it's a service that is made to take Active Directory objects. It really protects user accounts, especially if you have a high privilege, from accidental modification, deletion, etc. And so if you have admin privileges, you can abuse what's called the SD prop process. And if you want to, you need to go through and look up each of these processes to go deep into how Active Directory works. But again, what you can do then is have access to everything with a generic all. Another one is using a WMI subscription. And a lot of these topics are pretty huge. There are so many things you can do with WMI. So in this case, what we're doing is we're using an event subscription. So you can subscribe to events. You know, Event Manager on Windows, where it gives you all your system and application, startup events, and so on. You could subscribe to an event on another computer. So if you look over here, we have a PowerLurk. So we have a command prompt over here. And what we're doing is we are just using a very long command. You'd have to zoom in on this to see what we're doing. But what we're doing is we are creating an instance of that subscription in the command line. And then we're using PowerLurk down here to use that in order to maintain persistence on that system. And then we have a WMI persistence on the right-hand side. And in this case, what we're doing with an MSF console is we're running a getuid and other commands that eventually allow us to use WMI to maintain persistence on that computer system. Another attack would be overpass the hash. So we've already seen pass the hash attacks. But if you look at this slide here, you'll see that overpass the hash is actually pretty interesting. Using Mimikatz, you can get AES 128 NTLM RC4 or AES 256 keys for a Kerberos ticket. And it shows you an example of a screenshot of that. But again, you're going to use Mimikatz for this type of attack also. So let's talk about some post-exploitation. On Linux, there are so many commands. And one of the things I really like about our labs is we have a lot of Linux exercises. So if you look at some of these commands, find is one of my favorite Linux commands, especially when I'm doing hacking. And if I uploaded an executable or some other type of binary and I want to find it, what folder it's in, I can use a find. Chmod to overwrite accesses. Sudo can be abused using many different commands. You can find information about it. Permitted and forbidden commands. PS, so you can see what processes are running. Mount for file systems. A route to look at the routes that are available. And then cat. There's a cat where you take a file and dump it. In this case, you see it's cron tab that they're doing, looking at running jobs. And you can dump that to the screen, or you can use the redirection operator and cat it to a file. Then we have Windows. Let's have a look at these. There are a variety of post-exploitation commands. Here on the far left side is not only dir, which retrieves a bunch of names in the directory, but a different findStir. FindStir finds a string. So you put in quotes what you're trying to find, and you find it. Then we get service commands. We have a series of sc commands and netsh commands. I call them netsh, N-E-T-S-H. And what it does is it gives you firewall information and access. And then we have some wmic commands that we'll see right over here, where we can reboot Windows or display details. We have remote code execution commands, making use of wmic and taskkill and many other commands. So Windows and Linux have a variety of commands, and these are really just the beginning of what you can do, especially on Windows with the extensive list of commands you can do in PowerShell. You can take an AI, like for instance, a large language model, like maybe go to Perplexity and have it write for you commands to do specific things. Like if you want to find user information, you want to find hidden files and hidden directories, whatever it is, you can create scripts to do those, and PowerShell or Bash scripts. And even if you're not very familiar or you're not that good at it, you can iterate using that AI tool until you get the exact script that you need to run your post-exploitation fun. Okay, so now we are in the last objective, which is number 4. In the last objective, we're going to hide more stuff. We want to get rid of evidence of compromise. We don't want anybody to know that we are there. And so there are several things that we want to do to cover our tracks. So if you look over here on the far left, we can disable auditing, clear logs. We can manipulate logs. We can cover the tracks in the network and the operating system, deleting artifacts. We can disable Windows functionality. And so the first one we are going to look at in this case is a nice little command line tool that Windows has called Audit Pol. And if you look at it, it's audit and the pol is policy. So you can use this command to change anything about auditing on a Windows system. I've used it quite a lot in scripting. And you can use this, for instance, to disable auditing, or you might want to turn it off while you're hacking and then turn it back on, right? So that's what you can do with Audit Pol. And then clearing logs, there are some really cool little tools that you can use. One is called clear_event_viewer_logs.bat. Say that really fast. If you want to find this, you just do a little search for it online in quotes, and there's a place where you can download it and use it anytime you want. And of course, the baby universe of hacking, Metasploit, you can clear logs with Metasploit also. The next thing you want to look at is some of the PowerShell commands to clear the log. And over here, we have clear-event log. And we also have some of the parameters that we can put in for specific logs or systems, etc. And then over here on the right, we have WebUtil. And this also can be used to clear event logs. All right, so what about other ways of doing it? For Windows, I can go to the GUI and I can just right-click on the log that I want and delete it, clear it. For Linux, most of my logs are going to be in var logs. I go to var log and I can select the log I want and clear it or delete it. And then the next thing we want to do is clear our online tracks. And one thing that's really interesting to me is Microsoft came up with the idea of the Copilot PC. Are you familiar with the Copilot PC? So the Copilot PC, when it first came out, one of the controversial pieces of the Copilot PC is that it takes a snapshot of everything that you're doing on the desktop every few seconds. And so where you're opening things, using apps, clicking, typing messages, whatever, or maybe going places where you don't want people watching, it takes a snapshot all the time. Now, obviously you can turn it off if you want, but when that came out to such controversy, one thing I understand, and you should too, is Microsoft is already tracking quite a lot of what happens on that PC. When I say Microsoft, it has really nothing to do with the big company because they're not sending any of the data over there. But your PC has a lot of information about what you are doing. So we're going to look at some of the things that you can do to clear that here. And then a little bit later in this module, in this section in this module, we'll look at some of the other items that you need to clear for Windows. And you'll get a good idea for just how much is being tracked on Windows. So if you look at Windows 11, we have privacy settings in the personalization area. In the registry under HKey local machines, you go down to the Explorer recent docs. That's another area that you need to clear. On Linux, it's a lot easier. Linux tracks far fewer of the things that you do on Linux. So we can export his size to 0. If you want to disable it, to clear it, history-C or -W, for that current shell. So there are a few commands we can shred history, etc. on Linux. And then we want to cover our tracks on the network. So this is more about, let's say that I'm exfiltrating data back to one of my servers in my hacker cloud. I just made that term up, my hacker cloud. And I want to get that data back over there. Well, if I'm using normal techniques, that can be easily found. So there are 4 different techniques that we can use, and we're not going to go into how to do each one of these right now, but we'll do some of it in the lab. And one is making it look like HTTP with a reverse shell, or making it look like ICMP with an ICMP tunnel, or making it look like DNS, normal DNS traffic with DNS tunneling, or making it look like a regular TCP by varying TCP parameters. And it just looks like normal traffic, maybe a little bit more normal traffic than usual, but it still looks fairly normal, and we can exfiltrate data, infiltrate data, etc. using those 4 techniques. All right, now let's have a look at some of the areas I was talking about earlier with Windows, and we'll also look at Linux. So let's go over here to the left side of this slide here. And we already talked about this. This is a way to hide files on the system using ADS, alternative data streams. And so if I have stuff that I need to hide before I get it exfiltrated, that would be using ADS. It is as much of a deal in Linux, because all I'm going to do is put a dot in front of the file name, and it just doesn't show up as easily when I do an ls. And then I can cover my tracks by exporting hit size to 0, so you can't see what I was doing. On Windows, there's another really cool little tool called Cypher.exe. So if you have a look at this slide, you'll see that Cypher is used. I use it in scripting and so on. It's used to do many things, but one of the things we can do with it is overwrite, securely delete that data in a specific folder. So you see Cypher, and you give it that command with the parameters that you want, and you can completely delete a file. And then if you look at this one here, this slide here, we're disabling more functionality. So these are things that Windows is tracking. Last access, timestamp, Windows hibernation. That's a very big one. A lot of us use hibernation all the time. In fact, a lot of times your laptop or even your desktop has the off button mapped to hibernation. What is hibernation? Hibernation is a snapshot of the entire state of your desktop, of what you're doing right now. It's an entire snapshot, and it's stored in RAM. And so like I close my laptop, and there's a little trickle of power going to RAM to keep that state held in there. And then when I open it back up, boom, it comes back right away because it was hibernating. So hibernation is a snapshot of almost everything. So you definitely want to disable that. We also look at other items that you're being tracked. Your page file, you're being tracked. Your restore points, you're being tracked. And so they go to all the steps to get rid of that page file, delete that page file, stop it from being used, and disabling and deleting your restore points, because those are yet other ways Windows is tracking you. And then we also look at the thumbnail cache and prefetch. 2 more ways Windows is tracking you. And so if you don't want the organization or whoever owns that PC to know you're there, those are 2 other things you need to disable. All right, so now we look at this entire, there's like 5 different steps. What we're doing here is we're deleting Windows activity history, file access, application usage, browsing history. We're getting rid of all of that, again, because Microsoft is tracking it. So what we want to do now is also get rid of our incognito history, cookies from your browser. And so if somebody had an incognito window open or whatever with Windows, so right now, let's say that I was going to a site that I shouldn't visit. Let's come up with the Pirate Bay. You don't want to go there, believe me. So I was at the Pirate Bay, and I delete everything else, all those caches I was talking about before. But I can do an ipconfig/display DNS. And you'll see everywhere I went in DNS. You'd be surprised how much you can get from that. In fact, you might want to try it. Open up a terminal or command prompt and type in ipconfig put a space there, / display DNS, and you'll see everything that you have been doing. Hey, busted. We caught you there. But if you want to get rid of all that, you just do an ipconfig / flush DNS. Now, if you were to do that on your active computer that you're using right now for this class, then what will happen is all of those connections would have to be reestablished. So it usually doesn't disturb too much, but you can see that that's a good way to get rid of those tracks. And then for Mac, what we want to do is sudo kill all -info, and then you give it the MDNS server responder. So that is how you do it in your Mac. So ipconfig / display DNS, you can see everything. ipconfig / flush DNS, and you can get rid of everything in DNS. Well, the next thing we want to look at then is Windows, Linux, and Mac OS hiding artifacts. So at the far left side there, we are, let me ask you what we're doing. Check it out. We'll go over here, and we're in a command prompt. And what is it? I'm typing makedir, right? So I'm making a directory. It's called ceh_hack. All right, so I have stuff in there. And now for that directory I created, I typed in attrib -h -r -s ch_hack. What did I just do? Well, I added the attribute hidden, system, and read-only to that folder. So if somebody goes in there and does a dir, it won't show up unless they have made a special allowance to find those type of folders. Over here, we create a user, and then we disable the user. And then next time we get on that system, we want to use that account, we just re-enable it. Another one we can do on Linux, not as easy to do on Linux, is to hide a folder. And so what we're going to do here, it's hard to see this perhaps, but we have a dot in front of it like I talked about before, making it so that if I do an ls, it just doesn't show up automatically. And I can do some of that same in Mac OS by changing the flag to hidden on that file. All right, so anti-forensics. What is anti-forensics? Well, in IH&R, incident handling and response, when you are doing your forensics part of the incident response, what you're doing is you're looking for indicators of compromise. Those indicators of compromise could be IP addresses, they could be FQDNs, they could be ports or sockets or many other things. And so what I want to do with anti-forensics is I want to disturb the ability of the forensics team to find that information. So I delete the files or the folders or the activity. I protect folders that I have with passwords. I use steganography. I hide them in the file system structure. I minimize my footprint, just put a little bit here and a little bit there. I obfuscate my trail, maybe deleting logs. I wipe artifacts. I write ones and zeros over the last place that my binaries were located, and when I move them to a new place. I overwrite the metadata so that you can't go and pull metadata on any files. I use a program, Packer. So instead of being ihackyou.exe, it is write, Microsoft Write.exe. And it looks just like Microsoft Write, but a Packer put that together for me. And I can also anonymize my access into and out of that system through the network. And there are some tools that can help with some of this. If you look at some of the tools that we have over here, Dbond, CC Cleaner, Privacy Eraser, BleachBit, there are a lot of tools that you can use. So if you want to defend against somebody covering tracks when they're on your system, first thing you want to do is log. So if I'm logging continually and I'm exfiltrating those logs to a protected SIM system or something like that, where the attacker can't go back and get those logs, there'll be a discrepancy, and I'll know that somebody's been hacking. So we want to audit. We want to make sure that new events don't override old events. So for instance, in Microsoft Event Viewer, let's say that you told Event Viewer to store a maximum of 5 megabytes of events. And then you have FIFO, first in, first out after that, and it'll begin to overwrite. So what you do instead is you exfiltrate those events into a log server or a SIM where you never run out of space, never overwrite them. And then you want good permissions. You want to store those logs, update and patch the operating system, encrypt those log files, and make sure that your backups and your log file storage is on media that cannot be changed, indelible media. So for Module 6, we've gone through quite a lot. We started with looking at the SAM database, and we talked about hacking, getting passwords and usernames and tools that we can use and AI tools we can use. We talked about techniques to escalate privilege and hiding things like backdoors and creating and using keyloggers and other ways of hiding the evidence of compromise in the system. All right, so what we're going to do is two things. Number one, I would like you to join me in the labs as we practice some of this stuff. I think that when we do the Module 6 labs, you'll agree that these are some of the most exciting that we have. But in the next module, in Module 7, we're going to do something that a lot of attackers do, and that is make use of malware. So join me for the labs and for Module 7.